In this concise review of probability and statistics, we're going to cover three main topics: the MATLAB random number generator, we'll review the normal or Gaussian distribution, and show how to produce discrete histograms. And the MATLAB random number generator is called randn, R-A-N-D-N. And when you give the command randn m row comma n column, it's going to produce an m row times n column matrix of normally distributed random numbers with zero mean and a variance of 1. And the default seed, for example, if you want to generate a string of random numbers, you have to give a seed. And so you can use RNG default for a default seed, or you can specify certain integer feeds like 0 and 1. What we're going to do in this first example is create a vector of length 10. So we're generating it using the randn 10, 1 function. And here I'm showing the effect of three different seeds for this random number generator. First of all, if we use default, it's the left column of 10 numbers. If we use a 0 as the seed, then we get the second column of random numbers. And finally, if we use the number 1 as the seed, we get the third column of random numbers. So notice that each one of these sequences is different from another. The reason you may want to go with the same seed is, say you're doing two different simulations, but you want to compare two different algorithms on the same sequence of random numbers, then you might want to provide the same seed so that you're using the same random numbers. To review a normal distribution, you can see the definition shown above, where first of all we have the variance specified as sigma squared. That's also known as the standard deviation. We have the mean, and you see this calculation that I've written for this probability distribution in MATLAB code shown on the lower left-hand side of the screen, and that enables us then to draw this curve for the probability distribution. Now recall that if you integrate this function between minus sigma, 1 standard deviation below the mean, and plus sigma, 1 standard deviation above the mean, and you take the integral underneath that curve, that gives you the probability that any set of points will lie in that region. So in this particular case, taking that integral gives us 0.6827. That is 68.27% of the points in this distribution would be expected to lie between plus or minus 1 standard deviation. Similarly, if we go and do the integration of this function between minus 2 standard deviations and plus 2 standard deviations, we get 0.9545. That is 95.45% of the points would be expected to lie in the range of minus 2 standard deviations to plus 2 standard deviations from the mean. And finally, if we go plus or minus 3 standard deviations and look at the probability, that it's going to be 99.73% that the points that have been randomly generated will lie between plus or minus 3 standard deviations. And that's really the notion of 6 sigma, that you're lying between over a range of 6 standard deviations. So again, if we had 1,000 samples that were randomly generated using a Gaussian distribution, what we would find is we'd expect 1.35 to be below minus 3 standard deviations to the mean, 1.35 above 3 standard deviations to the mean, that 997.3 out of those 1,000 points would lie within plus or minus 3 standard deviations. Now, in reality, the distribution is discrete and not continuous. So now what we're going to do is we're going to use the MATLAB random number generator with 0 mean, standard deviation 1, and do simulations for different length sequences. That is for 1,000, 10,000, 100,000, and 1,000,000. And for each one of those, we'll calculate the mean and the standard deviation as shown in the formulas below. So for this first sequence of 10 points, you can see that I've generated them. They all lie between x value of -4 and +4. And we've got 10 points laid out. So what we want to do to develop a histogram is we're going to make bins, and we're going to count the number of points in each bin. So we're going to have, for example, bin 1 is going to be all the values of x that lie between -4 and -2. Bin 2 is going to be between -2 and 0. Bin 3 between 0 and 2. And bin 4 between 2 and 4. And we're going to count the numbers in each of those bins. And so if you look at this, you find that we end up with one of the data points is in bin 1, points is bin 2, 5 is in bin 3, and then finally 2 are in bin 4. And so then we can produce the histogram that's shown on the lower right-hand side of this slide. And we can also calculate the mean and standard deviation. Remember, this is only for 10 points. And so we had wanted to generate a distribution that had 0 mean and a standard deviation of 1. But when we do the calculation, the mean is actually 0.6 with a standard deviation of 1.7. So in reality, if you're going to approach the 0 mean, standard deviation 1, you're going to need far more than 10 points, because on the right-hand side, this clearly is not quite a Gaussian distribution. Now, to create the histogram that I showed on the lower right-hand side, we can use the function MATLAB histogram. And x is the vector of numbers, and edges is a vector that specifies the edges of each of those bins. So, for example, below, edges is defined as this vector of -4, and we're counting in lengths of 2 all the way up to 4. So that is, we're going between an x value of -4 up to +4, counting in widths of 2. So the first bin is starting at -2, has width 2, and the last bin ends at +4. Okay, and so again, that sequence ends is how we actually generated the histogram shown on the lower right-hand side. And now we're going to do this for longer and longer sequences. So here I've plotted a random sequence of 1,000 different points, again with 0 mean, standard deviation of 1 in the generator. And what we calculate is the mean is actually pretty close to 0, -0.0326, and a standard deviation 0.999. So we're already getting about as close to the expected mean and standard deviation as you can get. And you can see a lot of points lie between the ±1 standard deviation, even more between the ±2 standard deviations, and finally the vast majority ±3 standard deviations from the mean. Doing the same thing with 10,000 points, again we get means and standard deviations close to 0 and 1 respectively. And then we produce the histogram for a large number of points. You can see at 1,000 points, it doesn't quite look like a normal distribution. It's getting close, but not quite smooth enough. But really, by the time you're getting up to 10,000 and 100,000 points generated, certainly by the time you use 1,000,000 points, you get something very close to what looks like a normal distribution. And what I've done here is for the 1,000,000 points, I'm comparing the discrete probability distribution with the continuous, which I had to multiply by 0.1 to be consistent with the fact that we're using a bin width of 0.1 for the discrete simulations. So to summarize, what we've done in this screencast is show how to use the MATLAB random number generator. We've reviewed the normal Gaussian distribution and showed how to construct discrete histograms.